Hello students, how are you? So this topic is uniform circular motion. So this topic comes under kinematics and forces both because there is some forces part, that is centripetal force, centripetal acceleration, and there is motion of the body that is in the circular direction. So it comes under kinematics part also. So let's start with it. So first of all, you must be knowing that whenever there is an object and it goes in a like in a circular fashion, so this is velocity and this is velocity, suppose this is p and this is q. So the velocity magnitude is same for both p and q, but the direction is changing. So as the direction will change, there will be some change in the velocity because the direction is changing, and velocity is a vector quantity which has a magnitude and a direction. So direction is changing but magnitude is same. So first of all, before going up to this concept, first write what is angular velocity. Angular velocity is, the symbol is omega, and that is delta theta by delta t. So in linear motion, we say that a car has traveled up to this much of distance. So the change in the distance, or this distance s by t, is velocity. But here in the circular motion, we will discuss that this point has now reached up to this. So this is the theta. So this point has changed in radians. So delta theta by delta t, that how much degrees we have changed in what time. So this becomes omega, that is angular velocity. So angular velocity is 2 pi by t. So this we use in some angular velocity, and this is radians per second, whereas omega is equals to 2 pi f. So this we use in SHM motion. So both are same thing. Basically, the t is equals to 1 by f. Do not confuse, like whenever we use the similar terms in SHM, it becomes something different. It becomes angular frequency. So in SHM, we call it angular frequency, whereas here we call it angular velocity. So this is the basic concept for that, symbols and that all. So this is the total theta, that is the one round of theta is 2 pi, and this is the total time. So this becomes the omega. So after that, now we will be discussing this part, the centripetal part. So centripetal. So centripetal part is like, okay, I will rub it and draw it again. Suppose this vector is here and this vector is here, and very less theta we will take. So in vectors, we can move this vector up to here. So this is v, this is v. So change in v, delta v vector is this, because this is the v final and this is v initial. So this will be v final minus v initial. So this vector, is, would be like, if you will make this vector here, and then this will be the vector, and this vector will be passing through the center. That's why the acceleration is change of velocity by time. So the vector change of vector, the difference of velocity vector, is passing through the center and facing towards the center. That's why the acceleration vector will also pass through the center. That's why we say that centripetal force, centripetal acceleration, because this force will then come to like this, F equals to ma. So the direction of change in velocity, this one, is towards center. So the vector this is towards the center. So if this is towards the center, this will make acceleration towards center, this will make force towards the center. So that's the reason why the change in the velocity or the acceleration, why the acceleration is towards the center. So this is the first part. Second thing, the formula. Now there will be like, for the formula for acceleration is v omega, and we also know that v is equals to r omega. So we will put this here. So acceleration will become r omega square, and if you will remove this omega, this v by r, it will become v square by r. So we got these two formulas for centripetal acceleration. And one more formula I would be giving you. So the acceleration is like omega square r. So omega we have already discussed. Omega is 2 pi by t. So you can put it here. So it would be 2 pi by t whole square, and this is r. So it will become 4 pi square r by t square. So this formula is given in your book. So this is also important formula. These all are very important formulas. So basic key points in this is that whenever there is a circular motion, the acceleration will be always towards the center. This is the first point. And the second point is this. These are the formulas. That's it. This is the all about circular motion. And there is one other thing, that in many of the books they say like this is centripetal and this is centrifugal. So in many of the books they don't say it's centrifugal, they just say that there is no force, and they take centrifugal as a pseudo force. So take care and see your book that what they prefer to do. So this is all about the circular motion, and we are completed with this. Now we would be starting with the work, energy and power. Thank you for being here.